Hi everyone. Today we're going to be going over the practice problems in chapter 5.1, multiplying polynomials and principles of mathematics 10, which should be the grade 10 math textbook in Ontario. Okay, so question one, what binomial product does each model illustrate? So you see right here we have a snapshot from the textbook. So we know these big long ones are x's, and then these little squares are individual units. So we have for here x plus 1, and then for here we have 2x plus 3. If we expand that using the distribution principle, we have 2x squared plus 3x, then we get plus 2x plus 3. If we simplify, 2x squared plus 5x plus 3, just by combining like terms. Moving on to the next one. So the vertical side here, we have, same as before, x plus 1. And along the top, we have x plus 3. X. Now expand, although we're not required to, but we will. It's good practice. X squared plus 3x. And then we get plus x plus 3. Simplify. X squared plus 4x plus 3. Moving on to C. So C, it's a little bit easier for us because it's written out. So along the vertical, we have x plus 2. And along the top, we have x plus 2. So that can be written out as x plus 2 squared. But now if we simplify using this, we're going to be x squared plus 2x plus 2x plus 4. Simplify x squared plus 4x plus 4. Okay, now moving on to D. So along the vertical, we have x plus 3, and along the top, we have 2x plus 1. If we expand, we're going to have 2x squared plus x plus 6x plus 3, combine like terms, 2x squared plus 7x plus 3. Okay. Moving on to question 2. Model each binomial product using algebra tiles, virtual algebra tiles, or a diagram. So we'll use the tiles because it's a little easier. So it's just like the opposite of what we did in question 1. So 2x plus 1 and x plus 1. So we'll do x plus 1 along the vertical just because of the room here. So it's going to be like this. And then along the top, we're going to have this. And then it's going to give us a product like this. Now, if we count these, we should end up with 2x squared plus 3x here, here, and here, plus 1 here. If we expand this, we're going to get 2x squared plus 2x squared plus 2x. Then we're going to get here plus x plus the 1's plus 1, which equals our algebra tiles. Moving on to B. So we will do here x plus 4, 1, 2, 3, 4, and x plus 2. 1, 2. The product I'll do in a different color to make it a little easier. Now we're going to have 8 individual units here. And if we count those up, it should give us x squared, which is this guy. Then we got 1, 2, 3, 4, 5, 6, plus 6x, plus 8, which is this group. All right, so if you expand this, this is what that will equal. Now, moving on to C. So we'll do x plus 1 here, x plus 1, and x plus 5 along the top. Right, now if we do the product, we get, this is supposed to be a square, but my drawing's not the greatest. And all these little guys in here. Oh, actually, that is a mistake. They should be like this. These are single bars. And here are the little boxes. Now, if we expand this, count them up, we should get the x squared plus, so this is 1, 2, 3, 4, 5, 6x. And 1, 2, 3, 4, 5 plus 5. If we expand this guy here, this is exactly what we should get. Moving on to D. So we will do, we'll do 3x across the top. We'll start with that. So 1, 2, 3, and then 2. And we'll do 2x down the side. 2x, and then the single square. Sorry, my drawing, I know, is not the best. Now we will do the actual product. So this should be an x squared, x squared, x squared, x squared, x squared, x squared. This will be x, single x, and here is x, 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 and the individual units. Now if we count these up, we get 1, 2, 3, 4, 5, 6 x squared plus 1, 2, 3, 4, 5, 6, 7 x, and 1, 2. If we expand this to check, we get 6x squared plus 4x plus 3x plus 2. Simplify, this simplifies to 7x, and it's what it is. So by now you guys should notice that when we multiply a bar by a bar, we get bar squared. right, which is represents x. And the individual units, when a unit by a bar, you get a long bar, and a little unit by a little unit, you get a little unit here. Next page. So, question 3. Use a distributive property to find each product. Okay, so this is all just going to expand. So x times x and x times 5. We're going to do 3 times x and 3 times 5. So we get x squared plus 5x plus 3x plus 15. Now if we simplify this by collecting like terms, x squared plus 8x plus 15. The next one, x times x, x times 4, 3 times x, 3 times 4. X squared plus 4x plus 3x plus 12. Simplify by collecting like terms, x squared plus 7x plus 12. Let's go to the next one here. Don't let the change in variable throw you off. I mean, a variable is a variable. So same as before, y times y times 4, 2 times y, 2 times 4. So y squared plus 4y plus 2y plus 8. Collect the like terms, y squared plus 6y plus 8. Next one, same thing, except with r squared plus 2r plus 4r plus 8. Combine like terms, and we're left with r squared plus 6r plus 8. Question 3 continued. So same thing. I'm going to stop drawing the arrows now, and hopefully everyone can still follow along. So we are left with n squared plus n plus 7n plus 7. Combine like terms, n squared plus 8n plus 7. The p's, so p squared plus 9p plus 9p plus 9 times 9 is 81. Right? Now simplify. P squared plus 18p, 8 plus 81. W's, w squared plus 8w plus 7w plus 7 times 8 is 56. Just going to double check this on my calculator. Yep. Now collect like terms. We're left with w squared. Actually, let's clean that up a bit. W squared plus 15w plus 56. Okay, and for the d's here, I'll draw the arrows in. D times D, D times 11, 3 times D, 3 times 11. So we get D squared plus 11D plus 3D plus 33. Combine like terms, D squared plus 14D plus 33. What we got next? Okay, question 4. Use a distributive property to find each binomial product. Okay, so same thing what we've been doing here. So we got k squared. Oh, but now we have some negatives in here. Okay, k squared minus 5k minus 3k plus 15, k squared minus 8k plus 15. I'll draw the arrows for the next one as I go. So y times y squared. Y times negative 4 minus 4y. Negative 3 times y, negative 3y. Negative 3 times negative 4, which becomes a positive 12. Combine like terms, y squared minus 7y plus 12. Moving on to the x squared minus 4x minus 6x plus 8, x squared minus 10x. Oh, I made a mistake. Back up a little bit here. My apologies. So we were x squared minus 4x minus 2x plus 8. X squared minus 6x plus 8. My apologies on that. Moving on to the q's. Q squared minus 2q minus 4q plus 8. Combine like terms, q squared minus 6q plus 8. So if you notice, the solution is the exact same, except a difference in variable, because we know a times b is the same as b times a. You see here at first it's q minus 4 times q minus 2, and up here we have x minus 2, x minus 4. Moving on to e. So we have j squared minus j minus 7j plus 7. Now combine like terms, j squared minus 8j plus 7. Moving on to the next one. So here we have p's. So p squared minus 3p minus 9p plus 27. Combine and collect like terms, p squared minus 12p plus 27. Next we have, okay, we got two variables here. So we got to keep things organized. So z squared, right? And then we have negative 8xz. So z squared, negative 8xz minus 7xz minus 8 times 7 we know is 56, x squared. Combine like terms, z squared minus 15xz. Oh, this is actually supposed to be a plus, my apologies. Plus 56x squared. Last one here, b squared. Then we have negative 11bc, negative 3bc, negative 33c squared. Collect like terms, b squared minus 14bc minus 33c squared. On to the next one. Use the distributive product or property, to find each binomial product. And now it's just mixing in the plus and the negatives. So for the first couple, I'll draw the arrows. We have x squared minus 5x plus 3x minus 15, because we got a positive times a negative. Collect like terms, x squared negative 2x minus 15. Moving on, y squared minus 4y plus 3y minus 12, y squared minus y minus 12, collecting like terms there. So c squared plus 4c minus 2c minus 8, collecting like terms, c squared plus 2c minus 8. Next one, w's. So w squared plus 2w minus 4w minus 8, and collecting like terms, w squared minus 2w minus 8. Continuing question 5 here, we have m squared minus m plus 7m, minus 7, collecting like terms, plus 6m minus 7. Okay, y squared, then we have, what's that, plus 3y minus 9y, and then minus 27. Right, so collecting like terms, y squared minus 6y, the difference between 3 and negative 9, minus 27. Moving on here, x squared minus 8xy plus 7xy minus 56y squared, collect like terms, x squared minus xy minus 56y squared. And moving on to h, we have a squared minus 10ab plus 6ab minus 60b squared. Collect like terms here in the middle. A squared plus 50ab minus 60b squared. Question 6, find each binomial product. So hopefully by now the repetition has gotten you guys into a bit of a groove where you understand it more. But we're just going to keep going through these. 2x squared plus 8x plus 3x plus 12, 2x squared plus, what's that, 11x plus 12. So the next few we're going to do, but we're not going to collect like terms at the end. We're just going to leave the product as we find it. So we're going to, first one, 5y squared minus 7y minus 15y plus 21. So first two terms, 18c squared plus 30c minus c minus 5. 14w squared plus 7w minus 4w minus 2. Question 6. So first one, 25m squared. That's going to give us negative 30m plus 30m minus 36. Now, interesting about this is when we combine like terms, that those are going to drop off, and we're going to be left with this and this. Moving on. So this is 18y squared plus 18y minus 4y minus 4. That's a 4. Sorry, I'm just going through it in my head and make sure I did that correctly. 18y squared. Yep, okay. Next, we have 56d squared minus 42c. 5 times 8 is 40. So plus 40cd minus 30c squared. Next one, we have 42q squared. 6 times 12 is 72. Let me just double check that. 6 times 12, yep. So minus 72 QR plus 7 times 5 is 35 QR minus 60 r squared. Question 7. Okay, expand and simplify. So maybe we should have saved all that extra work for now. But when we're left with, see how all these other ones here, they're just two terms, or two brackets multiplied by each other. First, what we're going to do when we're left with something like this that has a term in a bracket, and a term outside the brackets, we're going to focus on the brackets first and then multiply everything by this 3. So remember that rule. So so we don't forget about the 3, we're going to leave it out there, and we're going to do the inside, x squared plus 6x minus 5x minus 30, and then we're going to bring the 3 in, 3x squared. As I do this, I'm going to simplify this term and multiply by 3. That becomes plus 3x, and this becomes plus 90. Oh, sorry, that is my bad. Oh, no, that was right. I apologize. Because this becomes, this simplifies down to 1x times 3. Moving on. So we're going to write the -2 so we don't forget. X squared minus 9x minus 7x. 9 times 7 is, let's see here, 9 times 7, 9 times 7, 63 plus 63. Now, we're going to simplify and add in the negative 2. So we get negative 2x squared. Negative 9 and negative 7 become negative 16 times negative 2 becomes plus 32x. And then negative 2 times 63 becomes negative 126. Moving on, don't forget this negative. When I do this, I like to write negative 1 outside the brackets. We'll get y squared minus 8y plus 2y minus 16. Now, same thing, left with negative y squared. Negative 8 and plus 2 becomes negative 6 times negative 1 becomes plus 6y plus 16. Moving on to k squared plus 7k plus 3k plus 21. That becomes 2k squared. 7 and 3 is 10. That becomes plus 20k. And then this becomes plus 42. Moving on. So write our m outside the bracket. M squared minus 5mn minus 3mn plus 15n squared. Now, this becomes m cubed minus 5m squared n minus 3m squared n plus 15mn squared. Combine our like terms now. M cubed minus 8m squared n plus 15mn squared. See this term here, I'll highlight it, these two terms, they're both m squared n. So we combine those two terms together to get negative 8m squared n. Oh, sorry. Okay. Last one. Oh, this is a big one. 2a. So we get 3a times 6a, 18a. Then we have plus 21ab. 6 times 4 is 24. 24ab. 4 times 7 is 28 plus 28b squared. And now simplifying, we get 36a squared. And then we have 42a squared b plus the next term, 48a squared b. And the next term times the last one. What's that? 56ab squared. Combine like terms. 36. Oh, I made a mistake. I see now. This first term here should be 18a squared. My apologies. Meaning this becomes a cubed. Okay? 36a cubed plus We're going to combine these two like terms. That becomes 100 a squared b plus 56 ab squared. Next question. Question 8. Okay, so we have to, I think, expand and simplify. I didn't write it down. Let me just double check real quick. And then textbook. Question 8, yes, expand and simplify. So first what we want to do is, we'll do this quick, guys. X squared plus 6x plus 4x plus 24 plus x squared plus 7x minus 7. Now, we got to start collecting like terms. Do this in a different color. X squared, we got these. Let's do all the x's. So 6 and 4 is 10, and 7 is 17, and minus 1 is 16. So we got all those, and now all the constants. 24, and this is supposed to be a negative 7. 24 minus 7 is 17, plus 17. Now we'll do the next one. We're going to start with this half first, because we got to handle this 2 separately. So 2, we got here 8x squared minus 44x plus 18x minus 99. We're going to add that 2 in. We are left with 16x squared minus 88x plus 36x. 99 and 2 is 198. Now we're going to add in the other part. So we have 6x squared minus 14x plus 15x minus, it's a minus 35. Now we're going to collect like terms. So let's do the x squared terms. That becomes 22. 22x squared. Let's do the x's. So I'm going to get my calculator for this one. That becomes 15 plus 36 minus 88 minus 14, negative 51. So we got these. And now we just have to do our constant terms, which is 35 and negative 198, or negative 35 and negative 198. Negative 198 minus 35, negative 233. Okay, moving on. So we'll do this part first. So remember, our 3 stays up front. This gives us 36x squared minus 6x minus 12x plus 2 plus 2. And then we're going to do subtract, and we'll leave everything in brackets here. We get 10x plus 10x squared plus 12x minus 15x minus 18. We're going to add the 3 in and distribute this negative. Okay, so 36 times 3 is 108. Oh, and I made another mistake. This is supposed to be x squared. 108x squared. This becomes negative 18x. This becomes negative 36x. And this becomes a plus 6. This then becomes a plus. Negative, this becomes minus 10x squared minus 12x plus 15 plus 18. Now, all we have to do is collect like terms. Let's do our x squared terms. So that becomes 98. 98x squared. Let's do our x's. Oh, this is supposed to be an x term. This is what I get for going too fast. This should be a lesson to everybody. Go slow, and hopefully you won't make these silly mistakes that I'm making here. Now, let's do this. We have 15 minus 12 minus 36 minus 18, negative 51. Negative 51x. And now just our constant terms. 18 and 6 is 24. Oh, okay, more to question 8. Let's go slow this time and not make any mistakes, guys. So, we're going to distribute this negative afterwards. So, x squared minus 3x minus 2x plus 6. Then we get 2. So, 3x squared. What's that? 3 and 4 is plus 12x plus 5x plus 20. No, negative x squared plus 3x plus 6x minus 6. Oh, shoot. See that? Going too fast again. That becomes, I did the addition in my head. This becomes, plus 2x minus 6. This then becomes 6x squared. Oh. Sorry, I'm getting tired over here. 6x squared plus 24x plus 10x plus 40. Let's collect like terms. Let's start with our x squared terms first. So this becomes 5x squared. Let's do our x's. 3 and 2 is 5, and 24 is 29, and 10 is 39. And let's do our constants. 40 and negative 6 is positive 34. Oh, okay, now the next one. Here, these are exponent 2. So it's the same as writing it out like this: x plus 4 squared minus x minus 4 squared. Okay? So we know x plus 4 squared is going to give us x squared plus 8x plus 16. Because we get 4x, when you write this out, it's x plus 4 times x plus 4. So you get 4x twice, which gives you 8x, and then 4 times 4 is 16. So now we have, excuse me, minus x squared minus 8x plus 16. And now if we write this out, x squared plus 8x plus 16 minus x squared plus 8x minus 16. Combine like terms. Let's do our x squareds. That becomes 0. X squared. Let's do our x's. 8x, 8x becomes 16x. And let's do our constants. Oh, what do you know? It becomes 0 as well. So final answer is 16x. Next one. Oh, another big one. Okay, let's move on here. So 5 outside the brackets. 15x squared minus 6x minus 5x plus 2, 30x squared minus 12x plus 15x, minus 6. Now, we have to distribute these negative 5 and the negative 6. 15 times negative 5 is 75. Negative 75x squared plus 30x plus 25x minus 10 plus 6 times 30 is 180 x squared. Negative 6 times 12 is 72x. Plus 6 times 15 is 90x. And 6 times negative 6 is negative 36. Combine like terms, 75 and that and 180. Negative 75 and 180 becomes 105x squared. 30 and 25 is 55. 55 and negative 162. Let's see on my calculator here. 55 minus 162 becomes negative 107. And now just the constants, and we get negative 46. Moving on. Question 9. The predicted flight path of a firework is defined by the horizontal relation h equals 2 times d minus 3 times d minus 15, where d is the horizontal distance in meters from a safety wall and h is the height in meters. Okay, so expand and simplify. So same thing, -2 out front. We get d squared minus 15d minus 3d plus 45. Now, continuing on, -2d squared plus 30d plus 6d minus 90. Collect like terms. -2d squared plus 36d minus 90. Okay, now verify the relation for part A is equivalent to the original relation. Use both relations to determine the height of the firework if d represents 10. Sorry. Very tired. So we'll do the second part first. So if d represents 10 meters, we'll use the original relation. So we know h at 10 is going to equal 2 times 10 minus 3 times 10 minus 15 equals 2 times 7 times -5 equals 2 times -30, -35. Oh, sorry, this is -2. I was going to say something's not adding up. And that becomes 70 meters. Right? Now, if we plug it into our equation, so we have -2 10 squared plus 36 times 10 minus 90. That's going to be -200 plus 360 minus 90. So this is going to become -200 and -90 is -290 plus 360. The difference is 70 meters. So they are the same. Next question. A square garden has side length x. One dimension is increased by 6 meters and the other is increased by 3 meters. Write an algebraic expression for the area of the original garden. Well, that's easy. Area is length times width. So we know x times x is going to be x squared. X times x. Simple. Write an algebraic expression for the area of the new garden. So now it's going to be x plus 6, x plus 3, x plus 6, x plus 3. Expand and simplify your expression from part B. X, oh, sorry, it's a little messy. X squared plus 3x plus 6x plus 18 becomes x squared plus 9x plus 18. Find an expression that represents the increase in area. Okay, well, if we look at it, the increase in area is the 6 and the 3, right? So this is our increase. Now, we know our original area is x squared. Our new area is x squared plus 9x plus 18. So our increase in area is simply 9x plus 18. Now, we can also use the algebraic tiles, right? And we can see that we would have, so we'd have 6 long ones here. There would be 6, 3, 4, 5, 6. There would be 3 here. 1, 2, 3. And then we'd have 6 times 3 individual units in here, right? Which would be 18, which matches up with what we had. 9x, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 18. There would be 18 small squares all in a grid here. Now, if x represents 12 meters, find the increase in area. So very simply, we just plug 12 into our increase formula. That's going to be equal to 9 times 144 plus 18, which is on my calculator here, equals 1296 plus 18 equals 1314 meters squared. Okay, so that is it for the first 10 practice problems. The next video will have questions 11 through 20. Thank you very much for watching, and please come back.